Welcome to another video in our series Commissioning a variTRON System. My name is Manfred Schleicher. I work at JUMO as a technical trainer, and today I will introduce you to the configuration program for the variTRON series. This is JUMO SmartWARE Setup variTRON. I will also expand the configuration from the last video to include a continuous control and show you how to work with the controller channel in the visualization. Here we go. And then I open the configuration program. No project is open in this view. Well, what can we do here now? First of all, I can see what version of the program this is. I can see here that this is program version 8. Then I have the program language here, which is English. Here I have the option of defined connection. In the last webinar, I defined a connection here for my variTRON 500 system. I called the connection webinar. Now I could also use this version of the program to create a connection for a variTRON 500 Touch, for example. To do this, I go to variTRON 500 Touch and I could create a new connection here accordingly. But I delete the connection again. Then I go to Projects and I can open a project here. This is how it is usually done, because a template is usually opened. I could also create a new project, but then I would also have to specify exactly what kind of CPU it is and what firmware it has. As a rule, you don't do this here because you are accessing the template. The template has also been created for very specific firmware. So I usually open a project here, and that's what I'm doing here. This is the project from the last webinar, and here you can see the project folder. The submenus duplicated in the Start view. It doesn't matter whether I go to the submenus via this menu bar or via the tiles. This means that the project management item exists twice. Accordingly, the hardware assistant and the configuration. So in this view, this is a duplication. I have now opened the project that I worked on the last webinar. I have already made a hardware detection. If I had simply opened the template, the hardware detection would still be necessary, and I would proceed as follows. I go to Data Transfer and here I connect to the CPU. I make sure that the correct connection is selected here at the top, which I can also recognize here by the IP address. I go to Connect and select Master 9200. This is a standard user with full access. And then I go to the hardware assistant and recognize the hardware by a scan. So the hardware in my file is adapted to the actual hardware. I go back to the Start view of the project folder, and here's the project management submenu. Here I can save my project, even under a different name. Here again is the hardware assistant, where I can view the hardware and also see, for example, which optional hardware exists in the controller module. This is a configuration menu, and here I notice that some texts are still displayed in German, despite the English language setting. This can be explained as follows. I have set the application language to English, but I can set the project language differently, and this is currently still German. Here I define that I want the project language to be the same as the application language. And now all texts are in English. I make basic settings in the configuration, such as the language of the system. This is set to English. This means that all texts are shown in English, both on the CPU display and in the visualization. Or here I can give the system a name to identify it. The input and output modules are configured under System Bus. Here I can see all the modules and can, for example, set up an analog input for the controller. If I want to do something with the programmer, for example, I do it in this area. The PT here stands for Process Technology. I make settings for data recording here. I can configure the recording groups here. Or I can make the settings for the data store here. For example, where the recorded data should be transferred to. This is where I set the cloud gateway. I will go into many more options in the webinar series, but for now I will just provide an overview. When I work with the template for the very first time, I have to start the CODESYS once. Then the hardware is also transferred here. I make this in PLC application. And in the last webinar, I showed you that I have to set the version of CODESYS that is correct for the system. I then start the CODESYS, take over the hardware and generate the program code, which must be error-free. Then I close the CODESYS and apply the changes here. I showed all of this in the last webinar. Okay, once we have completed the configuration, we go to data transfer and here I show you something special. I don't always have to transfer the entire configuration. I can do this selectively. Here I read send export, which means that the data or these data packets that I select here are transferred directly to the system. Almost everything is selected. In this example, I am not transferring the user management or the user administration. However, I would like to transfer these two so that I can log in to the system with the relevant rights. Now I transfer my project to the system. The controller channels of the controller modules are available in the template and I can also operate them from here. I would now like to put such a control channel into operation with you. Please imagine there is a system and the temperature is measured with a PD100 in a 3-wire circuit. So the temperature has to be controlled. I do the whole thing with a continuous controller. The controller outputs the output level via a 4 to 20 mA and uses it to control a thyristor power controller, which then changes the power for heating elements. Furthermore, the set point should be limited to 0 to 200 degrees Celsius. Now I would like to show you what is needed to put this control circuit into operation. I use an analog output from the controller module. Analog outputs are implemented in the controller module via optional cards. In the hardware assistant, I can see that there is such a module with an analog output in slot 2. And so I know that I have to use analog output 2 of the controller module. I start with configuring the controller module. The controller module is an input and output module, and these modules are configured under System Bus. For the PD100 in a 3-wire circuit, I use analog input 1, which I configure accordingly. I use the channel as a continuous controller and this setting is made now. I check that the source for the actual value is analog input 1. And here I can see that the set point is written via a network variable. In principle, I can see from NV that the set point is being written via the PLC. I don't change the setting, and so I can implement the set point input via the controller image in the visualization. Set point input is possible from 0 to 100 in the factory. I change this here to 0 to 200. I will use auto-tuning for the controller, and for this I have to specify again what output type the controller uses to control the actuator. In my case, the output type is continuous. Now I configure the output with which I output the output level. This is analog output 2, which I use to output the first output of controller channel 1. I set the signal to 4 to 20 mA, and with the specified scaling, 4 to 20 mA are output proportional to 0 to 100% controller output. This sets up the first control channel, and now I just have to transfer the configuration to the system. After the system has restarted, I call up the visualization in the CPU. I enter the IP address of variTRON 500 here again, followed by the port number 8080. I log in with the user master, password 9200, and enter a set point of 150 centigrades. The control channel outputs an output level of 100%, and so the process is heated. I start the auto-tuning from this view. The control channel alternates between 100% and 0% output level and calculates favorable control parameters by analyzing the temperature curve. I show the auto-tuning process here in fast-forward mode. The extinguished symbol for auto-tuning indicates that it has ended. And here I call up the determined control parameters. I still have a second parameter set for each channel. However, I don't need it in my small application, but in applications where it is necessary, I can switch to the second parameter set here. If the second parameter set is activated, I can see this on this display. To check the control behavior with the determined parameters, I change to the set point here. I can set the control channel to manual mode and specify any output level from 0 to 100%. This takes me back to automatic mode. Here I have the option of deactivating the controller channel. This means that I can set the controller signal to 0. So, those were the options in the controller screen, what I wanted to present to you. The controller has determined control parameters, and these have been saved in the controller module. However, I still want to transfer the parameters to the configuration program, and therefore I now have to transfer the configuration from variTRON 500 to my setup file. That's why I'm now switching to the configuration program. I'm in Data Transfer section. The readout from variTRON 500 is also selective, and I only want to read back the control parameters now. These are in the system bus item, and I therefore have to define that this item is to be read out. and I read the data from the system. And so the control parameters have also been adapted to the configuration program.